Good morning, dear students. Welcome back to physics class. Today, I am going to introduce new chapter which is thermodynamics. It is the 12th chapter from physics syllabus. The topics which are going to discuss for today class are A. Thermal equilibrium, B. Zeroth law of thermodynamics, and C. Definition of temperature. In mechanics, you have studied the motion, velocity and acceleration of an object. But in thermodynamics, it specifies the change in temperature and internal energy of a body or system. What is thermodynamics? It is that branch of physics which deals with concepts of heat and temperature and their relationship to energy and work. From one example, it can easily differentiate the thermodynamics from mechanics. In mechanics, if a bullet is fired from a gun, you will consider the motion of the bullet and its velocity, acceleration, etc. In thermodynamics, you can find it will discuss about the state of the object, which means that we have to consider the macroscopic variables like pressure, volume, and temperature. Consider the situation when the bullet fired from the gun hits a wall as shown in given figure. When it hits the wall, its kinetic energy gets converted to heat. Due to heat generation, there will be a change in temperature and the internal energy of the bullet. These are the macroscopic variables that you will study in thermodynamics. From this point of view, you have to mean that this subject is a macroscopic science which deals with bulk systems and tells us about the system as a whole. You know that macroscopic is opposite of microscopic, where we have considered the behavior of every molecule. This chapter tells about the laws of thermodynamics, which describes the system in terms of macroscopic variables, reversible and irreversible processes. While a gas is described in thermodynamics, it avoids the molecular description of the gas altogether. Instead of this, the state of the gas is specified by macroscopic variables. Thermodynamics laws are the working principle of heat engines, refrigerators, steam engine, Carnot engine, etc. Next discussing topic is thermal equilibrium. You know, equilibrium means balancing stage. In mechanics, a system is said to be in equilibrium if the net force acted on it is equal to 0. Then, what is the meaning of equilibrium in thermodynamics? It means all the macroscopic variables such as pressure, temperature and volume do not change with time. They are constant throughout. For example, consider two bodies at different temperatures. One is supposed to be at 30 degrees Celsius and another is supposed to be at 60 degrees Celsius. Then the heat energy will flow from body at high temperature to body at low temperature. Here, the body at high temperature is at 60 degrees Celsius and body at low temperature is at 30 degrees Celsius. Here, heat energy continues to flow till both bodies attain same temperature. This state when there is no heat energy flow between two bodies when they acquire the same temperature is known as thermal equilibrium. Let us consider two systems A and B. When they are said to be in thermal equilibrium, they are in thermal equilibrium if the temperatures of these two systems become equal after the heat flow. Let us consider a hot cup of coffee placed on a table. After some time, it will become cold. Here, there will be heat flow between the hot coffee and the surroundings. The cup of hot coffee becomes cold due to the exchange of heat energy between the system and the surroundings. When the cup of coffee attains the same temperature as that of surrounding, that is room temperature, then there will be no flow of heat energy. It shows the cup of coffee and the surrounding, which is air, attains in thermal equilibrium when the flow of heat energy will stop. Let us discuss on types of equilibrium. There are different types of equilibrium, which are thermal equilibrium, mechanical equilibrium, chemical equilibrium, thermodynamic equilibrium, etc. What is thermal equilibrium? Two systems are said to be in thermal equilibrium with each other if the temperatures of both the systems do not change with time. What is chemical equilibrium? Two systems are said to be in chemical equilibrium with each other if the composition of the system does not change over time. Then, what is mechanical equilibrium? Two systems are said to be in mechanical equilibrium with each other if the pressure of the system does not change with the time. Let's learn about thermodynamic equilibrium. A system is said to be in thermodynamic equilibrium when all of its macroscopic variables are constant. Let's learn about thermodynamic equilibrium. A system is said to be in thermodynamic equilibrium when all of its macroscopic variables are constant. Can you define system and surroundings? System is defined as any part of universe enclosed by some boundary through which exchange of heat takes place, and surrounding is any part of universe which is not a system. For example, if we consider a hot coffee in a kettle, then the kettle is the system and everything else is the surroundings. System and surroundings constitute universe. Let us see what are the different types of systems. First one is open system. In this system, there is exchange of heat energy and matter. Examples: water boils in a pan without lid, a cup of coffee, etc. Second one is closed system. In this system, exchange of matter does not take place, but exchange of energy takes place. Examples are a balloon filled with gas, pot with a lid closed, etc. In case of this pot, heat is getting transferred from gas stove to the pot, and also heat energy is transferred to the surroundings. But this pot does not allow the steam, which is a matter, to escape from it. Third one is isolated system. In this system, there is neither change in matter nor change in heat energy. For example, any closed insulated vessel like thermoflask. In thermoflask, tea can be kept hot for many hours because the walls of the thermoflask are insulated, so it does not allow heat energy to flow out of the flask. Now I am going to discuss on different types of walls which divide the system and the surroundings. You should understand a system can attain to be in thermal equilibrium with the surroundings if there is exchange of heat energy between the system and the surroundings. This exchange of heat energy is made possible only if the wall dividing the system and the surroundings conduct the heat energy. So, this wall is diathermic in nature. How to define diathermic wall? The wall which does not conduct heat energy is called diathermic wall. Its opposite nature wall is called adiabatic wall. So, there are two types of wall. They are A. Diathermic wall and B. Adiabatic wall. We can say diathermic wall is a conducting wall which allows the flow of heat energy between any two systems. Consider two systems A and B which are separated by a conducting wall. Suppose system A is at higher temperature T1, pressure P1 and volume V1, and system B is at lower temperature T2, pressure P2 and volume V2. There is flow of heat energy from the system at higher temperature to the system at lower temperature till the systems reach thermal equilibrium. For example, a vessel made up of metals like copper or aluminium has diathermic walls. Here, the system and surroundings are separated by a conducting wall. As shown in given figure, it is hot tea in a cup. It will become cold after some time as there will be flow of heat energy between tea and surroundings. And when temperature of the tea is in thermal equilibrium, then there will be no flow of heat energy. What is the second wall? I told earlier it is adiabatic wall. You have to mean it is an insulating wall. That is, it does not allow heat energy to flow from one system to another. This means temperature of both the systems won't change with time. Consider two systems A and B as shown in given figure, which are separated by adiabatic wall. Let pressure and volume of A be P1 V1 and B be P2 V2. You can see both of them will be at same temperature because for each of them there is no change of temperature with the time. Here there is no heat energy flow between the system A and B as they are separated by an adiabatic wall. You can separate both the systems A and B also from the surroundings by means of adiabatic wall. It means that there is no flow of heat energy between the system A and surroundings and also the system B and surroundings. For example, in case of thermoflask, tea or coffee remains hot for a long time as it is made of insulating walls, due to which there is no flow of heat energy between tea and surroundings. Now you are going to study about zeroth law of thermodynamics. Consider two systems A and B which are separated by an adiabatic wall while each is in contact with a third system C by means of a conducting wall. which is shown in first figure. The states of the system, which are defined by their macroscopic variables, will change until both A and B come to be in thermal equilibrium with C. After this is achieved, the adiabatic wall between A and B is replaced by a conducting wall, and C is insulated from A and B by means of an adiabatic wall, as shown in second figure. After this, it can observe that the states of A and B cannot change further. That is, they are found to be in thermal equilibrium with each other. This observation gives the basis of zeroth law of thermodynamics. Zeroth law of thermodynamics states that when two systems are in thermal equilibrium through a third system separately, then they are in thermal equilibrium with each other also. That is, if A and B are separately in thermal equilibrium with C, then TA is equal to Tc and Tb is equal to Tc. This implies that TA will be equal to Tb. Let's see how can define temperature with help of this thermodynamic law. Zeroth law of thermodynamics suggested that there should be some physical quantity which should have same value for the system to be in thermal equilibrium. This physical quantity which determines whether the system is in equilibrium or not is called temperature. So, it can say that temperature is the physical quantity which determines whether the system is in thermal equilibrium with the neighboring system. When the temperature becomes equal, then the flow of heat energy stops. Dear students, today's homework questions are given in this slide. Please, you have to work out these question answers by today itself. Okay, thank you. Have a nice day.